The world is becoming increasingly urban. 3 out of 4 people live in cities, with more and more following the trend. Cities will therefore require a greater amount of energy. Renewable sources of energy, however, tend to be located at great distances from cities. So when considering climate protection, one has to think about the following. How can traffic flows and the generation of heat and electricity become carbon neutral? And how can the transition to clean, sustainable energy be integrated into cities? In Kassel, Germany, scientists of the Fraunhofer IEE are looking for answers to these questions. Their focal point is the urban energy system, a new research branch of the institute. This new research focus unites all designated tasks aimed at establishing a sustainable energy supply for the future. It starts with developing sustainable concepts and providing the necessary planning tools and softwares. For example, coupling components, such as heat pumps and electric charging stations. The final aspect is the management of energy and the resulting business models. The successful execution of such tasks is critical to allow a shift to renewable energy in urban regions. The Fraunhofer scientists are looking for partners to work with them at their new research center, the Urban Energy System in Kassel. Such partners could range from housing associations and transport companies to energy and technology suppliers. The problem is that the energy supply for heat, transportation, and electricity have always been dealt with independent from one another. Fraunhofer researchers are therefore pursuing the goal of interlinking these energy sectors to establish a more efficient form of energy supply. In an apartment complex in Frankfurt, this concept has already been put into practice. There are more than 150 residential units here, encompassing an area of about 20,000 square meters. The unit was designed to consume as little energy as possible in order to reduce the overall heat demand of the building. In addition to this low-energy type of construction, other measures ensure the building's energy efficiency. The basement stores one of Europe's largest heat pumps. The pump utilizes waste heat emitted by the nearby wastewater system. Even in winter, the temperature here measures at least 12 degrees Celsius. This temperature level can rise to up to 40 degrees Celsius as it is densified by the pump using electric energy. In doing so, the pump has an electrical input of only 60 kilowatts. This generates a heating energy of 360 kilowatts, enough to supply the entire apartment complex with heat. The usage of electric energy throughout this process is highly efficient. This can be applied to other parts of the city. Frankfurt am Main has an extensive sewage canal network of around 1,600 kilometers in length. This provides great potential for heat energy right in the center of the city. The Fraunhofer scientists analyzed the amounts of heat waste and recorded on a geographic information system-based platform. Aided by digital planning tools, project partners are able to quickly identify such energy potential and can now incorporate it into their planning. If the heat pumps run exclusively on clean energy, the heat supply for buildings is thus CO2 neutral. To ensure that cities attain climate neutrality, it is crucial to identify heat waste potential as an energy source and combine it with renewable energy sources to allow for an optimization of integrated energy. The goal is to manage energy in such a way as to guarantee the efficient utilization of renewable energy. If heat pumps were to make use of the entire potential the German canalization network has to offer, this one measure could reduce CO2 emissions by 1% in Germany. And canalization is not the only heat waste potential cities have to offer. Temperatures in subway shafts rarely sink below 12 degrees Celsius. The Fraunhofer scientists, using digital planning tools, analyze this potential source of heat energy as well. There are several hundred megawatt hours that could be utilized each year. The Main River is also full of potential. The river has an average annual temperature of nearly 14 degrees Celsius and flows past Frankfurt with a water mass of around 150 cubic meters per second. This would provide environmental heat of a few hundred megawatts. The Fraunhofer scientists are not looking solely at bigger cities for heat waste potential. In Germany, around 80% of buildings are more than 25 years old. In many cases, construction doesn't meet modern energy efficiency standards. It can be difficult to find investors for houses in need of renovation that are located outside of popular in-demand cities. Within the framework of the urban energy system, Fraunhofer scientists are developing specific tools to facilitate taking on-site inventory of buildings. Potential investors can now use an app to receive a quick overview. The low-energy renovation of historical building structures is an essential part of sustainability. It means people will move here and stay here. We offer solutions to any questions that come up during consulting, and that is an important part of sustainable urban development. In the city of Wolfshagen in Hesse, Germany, the number of inhabitants in this rural area remains stable due to the low-energy renovation of buildings. The digital tools that are revolutionizing the energy efficiency of today are consistently modernized and further developed in the Fraunhofer Institute in Kassel. The scientists are utilizing both the data from the apps and experiences of its users. An increase in efficiency would be possible in whole neighborhoods. Like here in this housing development from the 1970s in Frankfurt, with a thermal power station, heating grid, and solar thermic facility all connected. Additionally, the Fraunhofer scientists on the urban energy system team are developing prefabricated facade elements. In conjunction with their digital tools, these elements can also speed up the renovation of old buildings. Another important challenge of urban planning in the coming years will be electromobility. There are specific questions that are essential for an ideal management of energy. How do I rely on mainly renewable energy sources for electric vehicles? And where do I fit electric charging stations into urban spaces? Moreover, alongside new energy consumers, additional new energy producers must be connected to the grid. The installation of an intelligent measuring system offers energy suppliers the opportunity to establish themselves and their products on the market. The introduction of variable electricity tariffs creates new business models. This is a challenge electricity providers must face. In order to support these suppliers, the Fraunhofer scientists are testing their new business models in their own control room under realistic conditions. This tells energy providers if their schemes have a chance of success in the face of an increasingly volatile energy supply in the market. Regardless of new marketing opportunities for energy services, innovative energy management, or energy efficiency and integration, in this active townhouse in Frankfurt, many of these concepts have already been implemented. This building generates more energy than its inhabitants consume. It was constructed by one of the largest housing associations in Germany, the ABG in Frankfurt. If we are to conduct research and development here, we need a reliable, strong partner like Fraunhofer. And our cooperation has been solid for years. This cooperation will be nurtured in the years to come. In the course of their work, the Fraunhofer scientists in Kassel have developed extensive concepts that perfectly target the needs of a specific region. They create their own laboratory infrastructure and at the same time connect and cooperate with international and local partners. Companies are invited to participate in the urban energy system, housing associations or component manufacturers or energy suppliers to transform the urban energy revolution. The urban energy system of the Fraunhofer IEE is making a significant contribution to bringing the energy revolution to the city. This way, the urban space, no matter the size of the city, can develop sustainably. And this is an existential contribution to climate protection.